So, welcome to today's Tech Hour. It's Thursday, the 24th of September, and I'm really pleased to have a long-standing member of the tech community, Nelson Beebe, who's going to be talking about BibTeX, and it's in the context of we're nearly at the end of the first quarter of the 21st century, which makes me feel very old. But we're a quarter of the way through our century almost. We've only got 18 months or 15 months. Oh, no, we've got a bit more than that. Yeah. So what I'm looking at is are there any things that we can think of now that we can accomplish by the end of 2025 that would make a difference? And I said there are extra points for things that are lingering on from the previous century. And I think Nelson has got a few things of that nature from BibTeX. So at that point, I'll just hand over to Nelson.
Okay. I've been battling a cough for the last few weeks, so I may have to occasionally drink some water to lubricate. The notes that I sent to Jonathan and he summarized and posted on TechHacks and the Tech Live list had links to, let's see, if I scroll back here, there was a link to a tutorial in BibTeX and two papers that I wrote about BibTeX and about BibTeX and SQL databases. And those provide a substantial amount of detail. Some people think that BibTeX is a LaTeX component. It's not. It's a tech component, and it's really quite general. It doesn't even have to produce text because its output is governed by style files written in a rather strange language, the BibTeX style language, that could be formatted for some completely different bibliographic reference system. So it's really quite flexible. And one of the ramifications of that is that I try very hard not to use LaTeX specific markup in BibTeX entries. I also try hard, in fact, I insist on keeping the BibTeX files exclusively in ASCII. So they have absolutely maximum portability. There are no issues of accented characters getting munged because someone has a different code page on their computer than someone else. And I'm assuming most of you have seen BibTeX entries, but Jonathan, could I do a screen share? Is that possible? I have one entry up that I'd like to use as a discussion point. I click on share screen. That one, and I say share. Does anyone see a buffer that says Emacs at some host name with Rutherford in the citation?
Yes.
Okay. I'll stretch this window if I can to see if I can get line breaks avoided. Yes, I think I can do that. And I can just about squeeze it on. Is the font big enough for you to read? It's always hard to tell when people are showing up at meetings with different size screens. I picked this entry because it shows a number of features of BibTeX that I wanted to discuss. First of all, someone who's never seen BibTeX before can have a pretty good idea of what this screen full of data is about. There's an author, there's a title, there's a journal name and a volume and so on, a year, a digital object identifier in URL form. The lines that are ISSN and ISSNL, those are the international standard serial numbers, which are assigned to serial publications, notably journals and magazines and book series. And the ISSN-L is the linking ISSN, which is a new addition to the system. It turns out that some publications have a fair number of different publication formats, and each of them has a different ISSN. For example, there might be print, there might be electronic. The electronic might occur in, say, EPUB format or ebook format or HTML. There might be a format that's in Braille and so on. And each of those would have a different ISSN. And the linking ISSN, which is nominally that of the oldest assigned ISSN, here the print form, is the one that can be used as a shorthand for all of them. And you can use these in library catalogs to look up things. As far as journal citation is concerned, if you think of reference lists in the back of a book, they have the author, the title, the year, sometimes publisher, journal name, volume, number, pages, day, month, and year, and so on. But it's useful to have other information recorded. In particular, in order to make sense of the myriad ways that journals can be abbreviated, I long ago adopted the convention that every journal that I cover pretty much has a standard handle, which starts out lowercase j dash, followed by the standard abbreviation for the journal to the extent that such things exist. My basis for this is normally the U.S. Library of Congress with their catalog records offering an abbreviated form. If the Library of Congress doesn't have it, I use the American Mathematical Society journal abbreviation. If that doesn't have it, I may have to dig some to come up with a suitable one. But this is keyed in a piece of software, journal.awk, to link the journal abbreviation to its long name, its abbreviated name, its ISSN, its code. And this particular entry does not have a code. CODEN is probably the oldest short form of journal abbreviations, introduced probably in the 1950s, perhaps earlier, by the American Chemical Society. Because it arose in the Chemical Society, there are not code and values for all journals in the world, but there are for most of those in science, notably chemistry and physics. And again, such numbers can be used for lookup. The ISSN and codons aren't values that a human can look at and make any sense of at all, because they're essentially random numbers for ISSNs and random letters for codons. Nevertheless, they do provide a unique handle, and that can lead you at some websites to more information about the journal. But this entry has some extra pieces of information here. I'll scroll it down a little bit. These are things that I've added in the roughly 3 decades I've been collecting bibliographic information. The first and important one is the bib date field, which is the date that this entry was added to the database or the database file. The second is the bib source line, is where did this thing come from on the web? So if someone were sent an email, this single entry, and they wondered, well, is there anything else about Ernest Rutherford? They could simply visit that URL and find a few thousand other entries. The URL field is sort of like the DOI, that is, it leads to an electronic form of the article. The difference, however, is that the URL field is that which existed at the time the article was published. And some people may not realize journals are commodities. They're sold from publisher to publisher. Some have had several during the course of their lives. So that URL at the Royal Society might not be valid if this journal were actually sold. Now, in this case, it's the Royal Society's own journal, so that's not going to happen. But it certainly does happen for many other journals. Whereas the DOI is intended to be a publisher and time-independent unique handle to an article. And it's the DOI agency's job to keep track of journals being sold from one publisher to another and remapping the DOI to a URL location where the user can actually find a copy of the article. The acknowledgement field here is just something that is sort of self-advertising, but I've used this in many bibliographies to indicate where did this data come from in the first place. And elsewhere in this file, that little string abbreviation for BibTeX is defined to expand to a physical address. The F journal field here is the full name of the journal, and it's a quaint feature of both the Royal Society and some publishers in Britain, notably Cambridge University, to have rather long journal names that might take 2 or 3 or 4 lines to write out in full. And often these will get abbreviated, so one might say the Royal Society A, if you're speaking to a colleague who knows this journal. But for citation purposes, one has to have this. I also frequently have an A journal field here, which is the abbreviated journal form. And then finally, there's a journal URL field here, which is where is this journal hosted at present. And that can take one back to the website for the journal, where you can find out how to submit a new article for the journal or to find back issues. So those are all pretty straightforward and relatively easy to understand, but I picked this one in particular because of 2 features. Number one, in the title, this one happens to have some mathematics. Lord Rutherford discovered alpha particles when he was at McGill University in the late 1890s. These are products of radiation that are essentially helium double plus ions. And so we have some math mode required here to get the Greek letter alpha. And radium C here, you'll notice that the C has got a brace around it. And the reason is that in those early days, they didn't really understand much about these kinds of particles. There were 3 kinds that Rutherford discovered, which he called alpha, beta, and gamma, the first 3 letters of the Greek alphabet. The beta particles turn out to be equivalent to electrons, and the gamma particles are light rays. But the C here is important because in the early days, they didn't understand the entire periodic table, and they noted that particular chemical processing on, say, a sample of radium would produce particular radiation patterns, and they just named these radium A, B, and C. It turned out later, as things were investigated more thoroughly, that these turned out to be different elements in the periodic table. And the reason the braces are around that C is it says that this cannot be downcased. Many journals typically downcase article titles and sometimes book titles as well. And the braces in the BibTeX title and also in a type field for a thesis protect it from downcasing. They also do that in the author field, and I picked this one because it's rather a complicated author. Ernest Rutherford started out as a farm boy in New Zealand, and but he later became Sir Ernest Rutherford and then Lord Ernest Rutherford. And the problem is that as far as BibTeX is concerned, when it sees a name like Donald Knuth, the styles are programmed such that if the journal typically abbreviates personal names to initials, Donald Knuth becomes D. Knuth. Well, the problem here is that you can't abbreviate Lord to L. It has to be kept as Lord, and so the braces ensure that. The other thing that's going on here is that it was traditional notably in Britain, but to a lesser extent in the US, up to, say, the 1940s, to include academic degrees and other honorary titles in people's names. So this is the Order of Merit from the British government and the Fellow of the Royal Society. And the second author here is noted as having a PhD, and the third author is noted as having a Bachelor of Arts. And the braces around those clusters then ensure that they're kept together and not downcased or further fiddled. So that's pretty much what I wanted to illustrate with the typical BibTeX entry. This system isn't perfect because when BibTeX was developed in the 1980s, I don't think most people understood that human names around the planet aren't universally of the form personal name followed by a family name. In Hungary and also to some extent Austria, because of the Austro-Hungarian Empire history, people would often put the family name first. So someone would introduce himself to you as Schmidt Hans. We would normally call him Hans Schmidt in most other European languages. So name order is a bit of a problem, and the convention in BibTeX is that the authors are separated not by commas or semicolons or other punctuation, but rather by the word and. And that's why it occurs there and also there. And it uses the and separator to break up a multi-author field into separate authors, each of which is then processed independently. The names can be abbreviated as needed. So I think that's all I want to say about that. We can go back to dropping the screen sharing. Let's see if I can turn this off now. If I can find the...
May I make a quick comment about that?
Yes, absolutely.
Thank you. I really appreciate that. I use BibTeX all the time, and I use PubMed, and I have a little program that converts the PubMed entry directly into BibTeX, takes the first author, last author, and the year, and puts those together as the key. And then then when I read that paper, I say, oh, this cites this other paper. I get the other paper, and I make a note, which I call a comment, which cites the other reference. So similar to yours, except that all of the BibTeX entries are strung together. And if I get something from email, that's in the actual email header line is in there. So I can trace back the source of where I got the reference exactly.
Yes, I'm going to find something like that in this bibliography. Just a moment here, and I'll do a reshare.
Right. So that means that I can figure out, if I have a paper, where I got it from and which papers it cites and stuff like that, which turns out to be quite useful sometimes.
Can you see this one that is Rutherford of Nelson in the label field? It has a note field down here that I'm highlighting that makes a reference to where this particular document was cited, and a note about its publication date, which is sometimes uncertain. One of the issues is that people have often been not terribly careful in making precise citations, especially of weekly and daily journals and magazines. Newspapers are typically daily. And the Times of London here, it was noted that it was published sometime after May 1934, but my university does not have a subscription to the Times archive, so I can't go in and access it and try to find this thing more precisely. But this idea of having a note field where there's a cross-reference is heavily used when errata and corrections and so on appear for a published article. I put two-way links in so that if the user of the bibliographic data cites the main paper, they will automatically get the corrections included in the bibliography list. Some publishers provide that as well on their web pages for the articles, but certainly not all do. And often you'll find journals whose contents include an item called corrections, but with no indication of what the corrections are. You might have to actually visit the article if you have access to it to find out what is it correcting. So, and I agree completely with Tom that these cross-references are extremely useful. I also wanted to make a point here of about the citation label. The scheme I adopted after experimenting with several different ones was to take the first author's family name. In this case, it's this long name, Rutherford of Nelson. Nelson has nothing to do with me. It's the town in New Zealand where Ernest Rutherford was born near, and use that as the first part of the citation label, that part, then a colon, and then the year of publication, and then up to 3 letters that abbreviate important words in the title, ignoring articles and conjunctions, so PAF. The reason for doing it this way is that a human and a computer program can generally agree on what that label is. That means a computer program can generate these labels automatically for potentially millions of entries, and they're relatively short. The year is intentionally set off as a 4-digit year there because if you refer to a paper of Smith 16, is that 1916, 2016, 1816? 2-digit years were a terrible idea. We had the world economy spending between $600 billion and $1 trillion fixing the Y2K problem a little over 2 decades ago. So I don't ever want to go back to 2-digit years. But this kind of handle is for most journals turns out to be unique. The case where it doesn't is when you have a regular column that appears in a journal. For example, most Elsevier journals have an item in every issue called editorial board, and it has its own DOI. It's a citable document, and so it would become .:EB, and so I have to add suffixes A, B, C, D, and so on to disambiguate. But it's a relatively simple system, and it's worked pretty well, and it keeps the citations inside documents, as in this full citation command here, relatively compact. If you look at what some publishers that produce BibTeX output do, they produce extraordinarily long citation labels, or like the American Math Society does, they produce a numeric citation. The trouble with both of those is that it's almost impossible to get them right. And when you look at a numeric one, you have no idea what it's referring to, and it's far too easy to make a mistake. If I see Knuth : 1984 : TB, I know that's the textbook. So I get many fewer errors from incorrect citations by this scheme. And after pushing 2 million entries, it's worked quite well.
So when I do it, I always, as I said, I always do the first author, last author, and year, and I go first author, last name, dot, second author or last author, and the year. And most of my papers, although include, well, it's biological in PubMed, and it turns out that that's almost always unique. So I don't need an extra tag on the end, and I don't have colons. It's an interesting idea to have colons, but I don't. And then if that isn't unique, like an author and their last person published twice, I'll go A, B, C. And I don't think I've ever gotten to D for the duplicates.
Yeah.
So 99% of the time, that can be generated automatically and be unique. And the program I have that grabs the BibTeX, grabs the PubMed data, automatically checks whether or not I have the entry already. And it compares them. If they're identical, says you already have this. And if they're not identical, then it shows me the difference between the two.
Good. Yeah, excellent.
Another note is that if you have a note and you put that, when you use LaTeX and you cite the thing, then the note, of course, gets displayed. But if you have a /URL, then that URL becomes active. And I do that for my DOIs. So all my papers have a DOI inside a note. And I don't use note for something else. I use comment, which is a non, that's never picked up.
Yeah, I use remark for the same reason.
There you go.
It's useful to have commentary
Right
inside a BibTeX entry, and sometimes I have a dozen or more remarks.
Exactly.
Especially important paper, you may want to cite different parts of it and quote a sentence or two.
Quote sections and why did I get this paper and what's important about it and stuff like that, right? But you don't want to put that in your references.
Jonathan's got his hand up.
Yeah, I'd like to sort of broaden the discussion. I've got my own agenda, which I'm going to hold back a little bit. Particularly if you haven't spoken, or you've got something new to say, then chip in. I think we're going to open up the general discussion now, Nelson. Is that good for you?
Yeah, that's fine.
Okay. So your chance to have the ear of Nelson for a minute or two.
I've always used, in archaeology, we have a lot of volumes of collected papers, and under a title of their own. And I consistently use the cross-ref mechanism, so that I didn't have to put in the book title every single time. I didn't have to put in the publisher every single time. And the way I've done that with my own, and now I've only got my own personal library, so it's small compared to what you're dealing with, is I just keep the collected volumes in a separate BibTeX file. And when I run them through LaTeX, I use them sequentially, so it picks up those references. I don't know whether that's a good thing or a bad thing, so I just wanted to.
No, I think it's definitely a good thing. I use the in proceedings and in collection types with the cross-reference to an entry that has the description of the complete volume, because you may want to cite the complete volume, or you may just want to cite one of the chapters.
Yeah, that happens all the time in archaeology.
That avoids duplication, and BibTeX does a fairly good job of merging the two pieces of data in one publication list.
Yeah. The one sort of publication we get in archaeology which doesn't fit often are excavation reports, where you'll have an author and then dozens of people who've written little specialist bits of it, which may or may not have their own titles and all sorts of things. And that can be quite often a bit fiddly to cite in a consistent sort of way. They're a bit odd because they're not like a collection of papers from a conference or a book which is a collection of papers. It is one report, but often written by a couple of dozen people doing the bone report and the pot report and the coin report and the this, that, and the other. And often they're interwoven with each other, so it can make it quite difficult to cite consistently.
So you're speaking.
Norman.
No, so someone else is speaking. So I think someone else came in just first there.
No, you're on, Norman.
Okay. I think that touches on another feature. I think this feature of BibTeX, which it is still quite specialized to the physical sciences, and trying to record bibliographic data for humanities-friendly contexts can be quite tricky, because they have a set of very intricate citation practices which are hamstrung, I think, by being forced into BibTeX. So that, I mean, in all sorts of little ways. I mean, they can be got around, but it is having helped folks with that sort of thing, it can be quite frustrating trying to do that, because BibTeX it made the design made choices, and the designer was a computer scientist, and so it works very well for various of the sciences, and inevitably it's less strong elsewhere.
In scientific journals, you wouldn't see op-cit and op-loc and so on as abbreviations for previous citations in the document.
Yeah.
Physical science.
That thankfully in the social sciences is going out of fashion in a big way, I'm glad to say. There's nothing more frustrating than going through a giant book trying to find out what the reference is.
But I think of things like translator, for example, or
classical sources have their own system. And when you get Pliny 2004, you think, well, that's just looks ridiculous.
Exactly, yes. So there's multiple dates relevant here, and so on. So I think that I think it's just look at the publication practices in the humanities tend to be a little more textured, let's say. An example of archaeology dig reports are probably a very good example of where a perfectly natural process in one area is bizarre to BibTeX.
Yeah.
Another area where things are quite different is the field of law. And there's a LaTeX package called JuraBib, which tries to deal with that to a certain extent. But legal systems in various countries have their own rather strict practices of how cases are cited. and it takes extra markup and thought. And I fortunately have not had to deal with that.
Yeah.
Nelson made exactly the point I was going to make, but in a different way. Yeah, there's a very strong tradition in legal systems of citing things. For various reasons, I'm interested in various cases in the United States, and they cite URLs as URLs. They just put the URL in. But there are lots of rules in law, and it's a sort of specialist domain, and it's, as you say, country to country. There's somebody I know of whose name I think is Sussman, who is quite concerned to develop an information system that deals with law, because in a sense, all these legal things are highly cross-referenced documents. And if we go back to the beginnings of print, law was one of the big areas where print made a revolution, because print allowed Tycho Brahe to publish his star catalogue, his observations. And it also allowed the legal system to publish the laws of England. Whereas previously the laws of England were manuscripts, and they're sort of whatever the king said it was, and if you're lucky, it was written down. And that's what things like Magna Carta, which is our 13th century version of the Declaration of Independence. So law is a big area where references and citations are really important. And what's interesting about law is that each document in a case will reference other documents in the case. So the concurrency, if you like, is quite strong, quite high. I'll say enough. Oh, the other thing I want to say is there's somebody, I think, whose name is Frank Bennett, who is in the tech community, or was in the tech community. He was at SOAS, who's done a lot of work in that area. So our community does have connections with legal citation and legal systems. And I think he's part of a group of people that have developed a legal information system. So if we think of scientific literature as data or records in an information system, then BibTeX is again part of that information system. And then there's the legal information system and all sorts of other information systems. And Nelson's other bow to his BibTeX arrow is the use of SQL to retrieve, search for information and that sort of thing. I've given a liberal speech, so I'll stop now.
Yeah, just one comment on the law documents. Often those documents have numbered paragraphs and even numbered lines. And so it lets someone make a cross-reference really quite precise to a particular sentence in another legal case or law. And certainly that's important. In the United States, a lot of this is now in an electronic database called Westlaw that law schools tend to subscribe to. I've never actually seen it myself because I'm not in that anywhere near the School of Law. I've given one lecture there. That's all I've done there. So there certainly are traditions, and I'm sure in things like the military and inside government agencies, there are probably fairly strong traditions of citing in certain ways. The important thing is that the citations should be clear and unambiguous, and that really should be the driving force.
No, Norman, you had your hand up.
Yeah. Yes, I think that what's relevant here is just to observe that the BibTeX is extensible because of course the set of article types and the set of fields within those are defined purely by the BibTeX style files, the BibTeX programs, and that's a very interesting thing. So the document, for those who aren't necessarily aware, that the documented set of articles of object types and names is described in the BibTeX documentation, but it's implemented and specified to the extent that it's specified only in the programs. And one can write those. One can write more programs, but there's two problems with that. two difficult challenges with that. One is that language is entertainingly awful. I mean, I do enjoy writing it, but it is dreadful. And the other is that the set of that when a program when a BibTeX style file effectively defines extensions to BibTeX, either types or fields, there's no way of, in a sense, registering them or even advertising them. And so I think I have at least once tried to float the idea of a registry of extended types without much success, really. But I think that is a sort of thing that is worthy of coordination, and something that I've sort of prodded around myself and with playing with BibTeX parsers myself.
I'm grateful to that. Is anybody who's not spoken want to speak? They get priority at this point.
I'd like priority, please.
You've got it.
Thank you. Slight segue. I'd like to talk about downstream. So BibTeX is how you store the information, but of course you run it through BSP and you get a BBL file, which is your, what's published. That's the standard way. So I'm in the publishing business, if you like. We have to deal with papers that are submitted, and more often than not, we get a huge LaTeX file with the BBL file. So it's formatted, it could be anything there according to this, to some, whatever the style is. And of course, the problem, we don't have the BibTeX file. Most publishers are not good at asking for the BibTeX file. And our problem has been that we've got to basically put the toothpaste back in the tube because it really is mangled when it comes out. So I did some work on this myself, and we were surprised. We did put a lot of toothpaste back in the tube. I haven't got my hand on the program, but you run a kind, excuse me. There are, of course, hundreds of these styles, or thousands perhaps. But basically, we surprised that we could do quite a lot. So we wrote started with a regular expression, a set of complex regular expressions, see if that matches that regular expression. If it does, would then reverse engineer. But of course, one regex is not going to do it. So with the regular expression, you get for example, you get the list of authors out. Then you've got to work out from that list of authors how to get back to the authors, because the first author might have been reversed, Smith A, then A Jones. So that was quite fun. Just thought I'd mention that. And I've looked around for any converters. I think Boris Weitzman had written something, but I cannot find a really good converter. So I wrote it myself.
Yeah, I've created extended BibTeX styles that output in the BBL file wrappers around all of those fields so that you could actually automatically recover a BibTeX entry.
Perfect.
The American Math Society has a free service called MREF, which you can find at their website, where you can simply paste in the BBL file entry, and it will try to recover the BibTeX entry. Now, it only does that by being able to match within its own subject area. So if you paste in chemistry paper, it won't do anything for you. But if you have a theoretical physics or math paper, you can probably get a BibTeX entry back.
Tom's next.
Yeah, so obviously a solution would be go back to the original author and just get the BibTeX from them. But the problem is that people have, like I have a single file with, I think, at least 4,000 entries in it for all BibTeX. I call it all.bib. So it's everything I have. And then if I'm going to give somebody a BibTeX or a paper with the BibTeX, I have a program called SubBib, and I wrote it in BST what it does is it takes the original BST, the original BibTeX file, and pulls out just the ones you want and creates a new BibTeX.bib file. So it's I call it sub-bib. And then that way I can give somebody the BibTeX file, and that solves that problem. The other thing, at least in biology, for where we have PubMed, which is almost all of the biological references, I wrote a program called YVP, which stands for Year Volume Page. They don't use so much these days because I just throw things into Google. But if you say the year, volume, and page to PubMed, it comes back with the PubMed entry. So it's conceivable to take, instead of trying to go backwards, one can just take the year, volume, and page, isolate the PubMed entry, and then convert to BibTeX from there. And that might be a lot easier than trying to parse stuff, which I know can be. You always have some exception. 5,000 lines down, you have a dash, which blows your program, stuff like that. So.
Yeah,
Okay, so you.
Look, I'm gonna be the host and say that it's one of the rules that we give people an opportunity to leave at 7:30, so that they can leave gracefully if they want to, and they can stay afterwards if they want to. So that's what I'm doing now, and I'd like to try and sort of summarize everything a bit, so that those people that want to stay can get off to a good start for the continuation. Those people that want to leave have something to go home by. So the first thing is a story that Xerox, the developers of the Xerox Star, I think it was called, the predecessor of the Apple Mac, had a wonderful photocopier. You could put a document on it, and even if it was crumpled and had coffee rings and everything else on it, it will come out pristine. Wonderful. And the document could be burnt and charred, and it would still come out pristine. And the way it did that was that it worked only for special documents that had a barcode printed on them. And when you put the document onto photocopy, it says, oh, it's got a barcode. I'll see if I've got that document. And if so, I won't bother to scan it. I'll just give them a clean copy. And that's exactly what Tom is asking for. And that's exactly what Nelson is providing, is you're giving a barcode for every BibTeX record, and then you can deal with that. Now, to sort of summarize, I'm going to go back to 1993, which is when Nelson wrote his article. And because I've recently read it and summarized it, there's a serious deficiency in 1993 about BibTeX error reporting, such as unmatched quote marks. And Nelson hopes that this will be finished by the final version, BibTeX 1.0, which we don't have yet. And I think that's a 2025 goal, or at least something we should address as a 2025 goal. And Nelson actually said that the final BibTeX is expected, I'm going to quote you here, I'm sorry, Nelson, expected to appear when the LaTeX 3 development is completed. I don't know if the creation of BibTeX 1.0 will cause the creation of LaTeX 3 to appear, or whether it's going to be a quantum entanglement synchronicity or whatever, but they actually both go back to 1993.
Perhaps that will trigger the end of the world.
Well, I hope not, but if it is, then we will make sure it's properly referenced. Now, the other thing that I noted when I was reading the article was that we have a long reference. There are 32 references, all of which are to ISBNs, which have an ISBN given, except 5 items, which are tugboat articles, a couple of Bell technical reports, Brian Reed's scribe manual, and an article by Don Knuth on LR languages. There are no references to electronic resources in the references in 1993, but there is a section on software availability, which you can get using FTP. Now, FTP is largely discontinued now, but the whole context has changed since 1993. And a number of comments of particularly the references to law, have shown that BibTeX and LaTeX and Tech are part of information systems, document systems. And that's the big change in the context, is that instead of being a component for the production of printing plates by which marks can be put on pieces of paper, the virtual object has become the real object. Just as the virtual money, the paper money, paper money used to be what we now call virtual money. You didn't trust it, you trusted gold. But now we don't trust paper money, we trust the electronic money, or at least we use it a lot of the time. And the PDFs that we use to print with are now the real thing that we read on the screen a lot of the time. Certainly that's what I was doing when I was making my notes on Nelson's article. So this whole context has changed in 30 years. The whole information context has changed enormously in 30 years. And I'm going to put in my tuppence worth, which is I would like to see BibTeX and associated tools work in the browser, which is a major software platform, because I want the whole tech system to work in the browser, so that if somebody wants to use Tech and LaTeX, they don't have to install any software at all beyond a browser. That really, really reduces the barrier to entry. So that's my particular agenda item. And I've taken us up to past. I'm really glad that we've had this discussion, and I hope that many of you stay and continue it. It will be available on YouTube next week, if not over the weekend. And a big round of applause or thanks for Nelson, not only for all his work on BibTeX and associated tools, but for coming along and giving us a clear description of what's happening. Oh, there's one thing I want to say, which is for David Fielding, which is that the archive only takes the BBL files. It doesn't take the bibliography files that BibTeX takes as input. If I remember correctly, it doesn't run BibTeX, and encouraged not to. Yeah, and in a certain sense, that's to ensure reproducibility and to reduce the dependency on the tool chain. And Nelson did exactly the same thing in his article, because he said, well, you need Yak and Lex to build my software from scratch. But if all you've got is a C compiler, well, here are the ones here are the Bib and Lex outputs that you need. So that's precisely the attitude that the archive has taken. So we can't criticize the archive too strongly without at least having a little tut towards Nelson for saying, you should insist these people use Lex and everything. I'm deviating. We've had a really good meeting, and I hope that will continue. And I hope that in a month or two, perhaps sooner, we'll do something about databases and BibTeX, and we'll all meet again. So those that want to go can go. We'll just have a few minutes where people can say goodbyes if they want to, and those that want to stay can stay. Tom.
So I'm just curious how you would store data if you do everything on the browser. I mean, the data have to be stored somewhere. It could be stored locally in their computer, or it could be somewhere on a cloud, or would you have all of these options?
All browsers now come with SQLite. They can store an SQL database, and Nelson's techniques will, I'm sure, run well in a browser. The technology of the browsers are now very good at file storage. Norman.
It's not quite the same thing, but Overleaf, which some folk may know of, allows you access to a full LaTeX system via the browser, and it works very well. And there's a growing population of undergraduates who use LaTeX all the time, but have never installed it on a machine. And so that's not running in the browser, but it's certainly accessible and working better than I would have thought via the browser.
And where's the data stored?
on Overleaf's server.
On
So
their
it's in the
server.
cloud. Yeah. So it's a straightforward bang up the line cloud service,
Okay.
which has its advantages.
And observe that if you have a digital object identifier, the DOI agency website can return a BibTeX entry for that. Now, there's a caveat here, and that is they're a collecting point to get data contributed by publishers. For example, our own journal, Tugboat, has a fair number of its articles now uploaded to the DOI agency. And that's a longer term retrofitting process to get everything. And we're almost at 5,000 articles in Tugboat. So that's a substantial piece of work. The problem is that publishers are big, complicated organizations who often farm out their publishing work to other companies that are sometimes good and sometimes not so good in preparing data. And consequently, one does find errors in the BibTeX, in the metadata that crossref.org and the DOI agency hold. So you'll have misspelled author names or truncated author lists. Quite often, mathematics in titles has been totally garbage and mangled beyond repair. So it isn't perfect, but it's a pretty good start. And for simple types of articles, say in the humanities, that wouldn't need mathematics in titles, I'm sure it works quite well. And that already then provides a web accessible conversion of just this short handle, the DOI, to a BibTeX entry that can be then turned into a citation. Now, so we haven't seen any publishers yet going to a reference list style that simply is a list of DOIs, but that might happen. I noticed recently in one of the chemistry journals I was checking, when I looked at the entry in the PDF file on the screen in the reference list, the DOI was not there. But I discovered when I hovered the mouse over the entry, a ghost image of the DOI appeared. And so I could then click on that and it would take me to the publisher site for that article. And that's both good and bad. It keeps the bibliographies relatively short, but it's bad in that you have to hover the mouse and do a copy of the DOI for every single entry. I would much rather the DOI were visible, and that's what the DOI agency recommends them, that the DOI field in every reference list, the entry ought to end DOI colon 10 dot something, so that every publisher did it the same way, and software could do simple pattern recognition on it to recover DOI and fill in data that was missing or incorrect. Norman, you're muted.
There you go. Parenthetically, I think that the DOI recommendation from DOI.org is now to make it a URL rather than for what seems to me better, the DOI colon DOI. So I think they now suggest https://doi.org/ etc., which I don't think is great, but that's now I believe the current recommendation.
The reason my DOI fields have the URL form is that I can't depend on users, particularly new users, students, notably in my environment, knowing what a 10 dot something means. But if they see http:// oh, I've seen that before.
Yeah. I think that is a pragmatic motivation. Yeah.
They've seen URLs, and my DOI to BibTeX tool will strip off the HTTP part as needed or put it on and recover the entry. So it's quite happy to use either form. But I really wanted the entries to be obvious to someone who's never seen a BibTeX entry before. But the minute they see protocol colon // they say, oh, I can take that and paste it into a browser. If you pasted the bare DOI into the browser, it would not find it.
I think Tom wants to speak.
So you're saying, Nelson, that you have a tool, or that if you go to the DOI.org website, that they provide the BibTeX?
Let me just bring up the file here. just typing here. I'm a slow and lousy typer. And I'm just going to scroll through it and see what it's doing here.
Do you want to share your screen, Nelson?
Yes, I can. Where is the Zoom tool to do the screen? There's a share screen. Okay. So do you see, again, an Emacs buffer that starts out bin/sh minus?
Yep, we got it.
Right, so that's what the comment block for this tool, which is now almost 8 years old, does. And it has some operating system dependent stuff to pick paths to find things. But essentially, once it's got the DOI, which is down in this value $G here, it uses curl with this long magic string going to the DOI agency, and this field, accept application/x-BibTeX, is what tells the DOI agency, oh, I'd like to see this in BibTeX form.
Nice.
I'm going to say something very, very quickly, which is that if I was a web developer, I would use Ajax to make an asynchronous JavaScript call, and I'd hope that the DOI server would serve me the data in JSON, and then I could write a little form that does exactly the same as your shell script does.
Yeah.
And you know, anybody could cut and paste that and put it, so to speak, on their web page as a tool. So the logic of the tool is the same in both cases.
And fair number of the publishers I deal with offer at their websites for each of their journals a little button you can click to get either that entry in BibTeX form or a number of other formats, or get the entire issue in that form.
Yeah, I think what I'm saying is that, fingers crossed, there's you could put such a button that your shell script could be turned into a button on a web page. That's all I'm saying. And the other thing I'm saying is I think that would be a good idea.
Need is input field, paste the DOI here, and behind the scenes generate the curl call too. Yeah,
it does it well. It's not called a curl call. It's called asynchronous Java Ajax request, but it's the same protocol. Norman.
Well, within that bit of JavaScript, JavaScript can make effectively curl requests as well. So there's nothing special about the JavaScript there. And returning specifically BibTeX is probably a better design in that case. But both would be possible. So I think Java could probably retrieve the same URL that Nelson has constructed as things stand. JavaScript's a nicer language than one expects.
The browser is a very competent device at this point in time. It's an important platform. And in 1993, Nelson talked about portability and how he used standard STIR and all sorts of things like that. And he did all the right things at the time. But the browser was nothing in 1993. And now the browser is a very important platform. I'm speaking to you through my browser.
Yeah, we all are.
Yeah, and that is one of the really big changes that's happened in the computing environment. And the browser is one of the major devices by which we come into contact with an integrated data environment. And if something isn't in that integrated data environment, it's the same as not having a telephone or postal address. Norman, you've been very polite.
Oh, you can't shut me up. I have to go before too long, but I was quite interested when you announced this particular session, because one of the prompts to, and changing topic slightly, mentioned that I've been doing some stuff on parsing BibTeX myself, largely as a procrastination project, and as something of an experiment. So this doesn't have much of a direction in mind, but I've been writing a tool which would parse most BibTeX and emit it in other forms, but also make it possible to process that in using a different language than BST. In fact, using Lisp, which is, of course, the correct language for everything. And as a proof of concept, I was able to re-implement the BST, most of the BST language in that. So that's not public yet, but I'm not very sure what direction I should push it in. But I think it might be of interest to some others, partly because it's a substantially nicer language to write bibliographies in than BST. Well, it's something more entertaining.
Yeah, I can recall there were two grad students at Berkeley in the mid-90s who did their master's degrees using Lisp as a way of representing textual data for typesetting and for bibliographies. And the nice thing about that idea is that you have the text form, the Lisp program, and say the BibTeX entry becomes, say, in the author field, open paren author, and then the quoted author. In other words, the name author there is not just a keyword for a human, it's a function name.
Yes.
Function name can take that string and now do something interesting with it.
Exactly.
So making data executable in a form that's relatively easy for a human to understand is useful. And several years ago, I wrote a tool to convert BibTeX into a Lisp-like form, and a companion tool to convert it back again, so you don't lose anything by the conversion.
An S expression and JSON and Python are some of the things this can produce, incidentally. But I think the most interesting thing was A, parsing, and B, replacing BST, potentially replacing BST as an alternative to doing this. So at some point I'm going to be brave enough to actually release this to other people, but I know who to prod when I do so.
I'm going to ask Nelson, if there's a senior person here regarding BibTeX, if he could give us some guidance as to, if he's willing to, the next 2 years. How do we negotiate the next 2 years? And it could be not do this, but what process do we follow rather than what do we do? But
well, it certainly has been frustrating that while BibTeX has been stable and absolutely rock solid and trustworthy, it never core dumps. It hasn't got the further development that one would have liked. And of course, Oren Patashnik, its original author, wrote it as part of his doctoral research. And then he graduated and got a job at the RAND Corporation in Santa Monica, where he lives today. So he's been involved in essentially confidential government research his entire career. And I have no idea what his workload is, but it certainly hasn't left him much time for BibTeX. He's told me that he has a long wish list of things that it would be nice to put into BibTeX, but he hasn't had the time to carry them through and wasn't satisfied that he had the final solution. Maybe the final solution will never exist, but it probably would not be deleterious for someone else to develop a completely independent implementation of BibTeX in whatever programming language they find convenient. It's pretty portable, whether that was Perl or Python or Java or JavaScript or PHP or any of a number of other choices, and put it out there and do it in such a way that the styles are much easier for a human to fiddle. one of the great nuisances is publishers take essentially the same data, author, title, journal, volume, and so on, and they represent it differently on the printed page by changing punctuation, using colons instead of semicolons and commas instead of periods and the like. And that's complete nonsense, of course. The human doesn't care about the punctuation marks. They just want to be able to understand what the entry is. And so it's really a great shame that most journal publishers seem to feel that it's up to them to design yet another unique style for their reference list, which is completely foolish. And it's just a waste of time. And the BibTeX styles are not easy to write. For those of you who've never looked at them, they're a reverse Polish notation. You put a list of operators or arguments on a stack, and then the last thing you put on the stack is the function name. The function name is then invoked, pops off its arguments, processes them, pushes the results back onto the stack. And although this is very efficient in terms of computer processing, PostScript works the same way as does a low-level language used in computer BIOSes. It has the problem that it's very hard to debug and to get right. And to make matters worse, in a conventional programming language, you give a function name followed by a list of arguments, and they're exhibited all at that point. But in PostScript and in the BibTeX style language, those arguments can be pushed onto the stack at various points in your program with no obvious connection between them. And then finally, you invoke the function that expects to find exactly the right arguments. And if you make a mistake, you get stack underflow or something of that sort. And it's very, very frustrating to deal with. And I would like a much simpler one. Ideally, you'd like a pattern that any human could write that says, for this particular journal, I want the reference list to look like A.B. Jones and comma D.C. Brown, comma E.F. Smith, and so on. And then have it figure out from that pattern what the output in the BBL file ought to look like. And that really hasn't happened properly. There's a certain amount of work that's been done. Patrick Daly developed sort of a generic style file generator that tries to do this, but I've not experimented with it. But I really think it needs to be made easier because we have publishers who are very insistent on following their particular styles. And we don't want this information to be like, it must be generated.
I put in the chat a link to CSL, which is, I think, which is so-called citation style language, which is an XML. I see Canberra nodding his head, which is intended to be a way of describing how citations should be laid out without being executable. I haven't investigated it.
I've heard of it. It looks promising. I think it's XSLT based, and XSLT is a language that could be improved or used in better ways. But
well, yeah, I have a vague notion that this thing I've been working on, I could implement that using that system as well. But that would be, I think, a bit of an effort. I think also what would be interesting is that it's true that, and I think I probably do have to go soon, but Nelson mentioned making another version, or the idea of making a complete version, a final version of BibTeX or an alternative version. And I think something that he laments in the article that Jonathan passed on is that BibTeX is somewhat underspecified and in rather frustrating ways. And it wouldn't be unreasonable, I think, for such an effort, if there were for such an effort for a parallel implementation of BibTeX, to say we are not going to be bug compatible or weirdness compatible. To select things are just regarded as acceptable by BibTeX, but not acceptable in practice. And that would be a challenging thing to decide what to drop, probably, but I think it might be a useful cleansing experience.
Yeah, the important thing is to give multiple people a platform that they can experiment with and try to see what features could we add to this, what could we do in the way of setting up rules for converting a BibTeX entry with key value pairs into a reference list item. And the heads of a lot of people would be much better at this than the head of a single or even a small group of people working.
I think that we're sort of moving towards the idea that there should be a period of discussion, and perhaps I'm suggesting an online meeting, perhaps a one-day meeting or something, where we discuss the past and future of reference management in terms of the tech community and others. I'm going to put in a different area, which is, okay, I'm a mathematician and there's mathematical databases. One of the ones I use a lot is the online encyclopedia of integer sequences. And I mean, there's the sequence numbers 0 to 8, 34, 144, which are the even Fibonacci numbers. I've been studying that a lot recently. And the website, it used to be a book, the website has as a key for each sequence about 20 or 30 terms of the sequence if it can manage it. And that is, so to speak, unique and can be put into a normal form. You know, the first 20 Fibonacci numbers are the same for everybody. Whereas the BibTeX record for a particular article might not be, you know, different people come up with different answers. So there's about 200,000 entries in the online encyclopedia, and you've got the number of the entry, which is your unique, your DOI, if you like. And then you've got all the data associated with the entry, which grows over time. You know, somebody will put in a conjecture and then somebody will say, here's a proof, or here's where you'll find a proof, that sort of thing. So these entries actually vary over time. And they're really important. And and there are other databases that have things like numbers or equivalent numbers. And I'm sure Tom knows of lots of databases of biological sequences of life. And there are databases of chemical information and planetary information. You know, there's all manner of databases that are sort of shared and socially constructed. They're not the Amazon customer list database. It's people, they're citizen science databases, if you like. So because those are always growing, there's always the need for them to have systems that work, that do things. And so on the one hand, we've got all the legacy stuff, which has to be preserved. And on the other hand, we've got all the newcomers. So I don't know what the state of play is regarding putting a reference to the OR online encyclopedia of integer sequence into a paper. And I don't know if there's a sort of standard way of getting this title, the name of the sequence. The sequence has a name, you know, which might be a mathematical formula. So there's that whole area. And mathematical research nowadays involves large numbers of databases, and with not machine learning, but with proof assistance, you're getting databases of proofs. So you're getting machine readable proofs of things. So there's a lot going on where the need to make references is going on. And at the same time, there's all the traditional stuff. And I think that the tension between the two can be both difficult and productive. So I've said my sixpence worth.
I put in a plug for the online encyclopedia of integer sequences as well. I found it quite useful. I'll tell you a little amusing anecdote. Several years ago, there was a new paper in the Journal of Mathematical Physics that had an intriguing title, and I printed out the paper and read it. And in the paper, the article, the authors commented, we have this strange, complicated summation, and when we add it up, it seems to come out some fraction of pi, but they couldn't prove that should be the case. But I happen to know some people who work in the pi research community, and I contacted two of them. Within a few weeks, they were able to come up not only with the proof that this was indeed the conjectured fraction of pi, but it was a completely new way of arriving, and a completely new, previously unknown series at arriving at pi. And so this opens up new areas of mathematical research. So it was a fun thing to do. And tools like the online encyclopedia, where you've done, say, a computation in physics, and you get a series, and you evaluate the first few terms, and they have integer values, and you feed those into the online encyclopedia and says, oh, this is a known function. It's the best function to have future arguments.
There's a very famous conjecture called the moonshine conjecture, which is the characters of a group called Monstrous Moonshine. There's the character table of the group, the monster group, which is absolutely enormous. It's a sporadic, finite, simple group. And something to do with the invariance of an elliptic function. And these two sequences of numbers after a small adjustment are the same. And they're enormous numbers. And Richard Walshard's got the Fields Medal for proving this. And the method required vertex algebras and ideas and methods of quantum physics. Underlying it was some sort of understanding of quantum physics. The quantum physics isn't needed for the proof, but it's needed to think your way to the proof. Tom, would you like to be the biologist?
I am a biologist, theoretical biologist. I'm sorry, I'm missing what you're asking for.
Well, just do you have things that you need to reference that are not articles?
Pretty rarely. I mean, I'll put a miscellaneous entry in, but most of my stuff is biological, and therefore it's in PubMed. Unfortunately, PubMed doesn't think that things like agriculture are that important because it's not biomedical. It's outside that range, and so they don't always have references in ecology, for example, which is a big thing for me now. But when it's in PubMed, then the conversion is pretty straightforward. And I think what I should do actually is talk to National Library of Medicine who do PubMed and see if I can get them to take my little script and put it in as a feature that you just click on this and you get the BibTeX entry for the paper. And then a note, I just saw a talk today where they gave the PubMed numbers. So they said such and such a name. They didn't even give the year. They said PubMed ID. They gave the number, which is great because from there you get the reference. And then from there you go to the actual paper because they give the DOI and everything. So National Library of Medicine is continuing to do a great job. And they are also the same people who do GenBank. So they carry all of the DNA sequences of everything. And every couple days, they sequence a new platypus species or something, and you can get the whole genome and all that out there. So speaking of large databases, now there are multiple databases for entire human sequences, and the entire human genome is, of course, it used to be done, and now it's really done where all the repeated stuff is completed. So that's a resource.
Because National Library of Medicine also, firstly, PubMed is really a standard in your area where it's a compact number, and that's it. That's all you need. UI is a little bit more verbose. And of course, National Library of Medicine also JATS XML is their the NLM that became JATS. So they've done a lot of good things for making publishing better. If I can just go back to what we were saying about a little while ago, we were saying about how Nelson was saying how publishers each one wants to have their own style, which is nuts. So many styles. Have a comma before this, then et al. Yes, have a comma before et al. No, not have a comma before et al. And of course, this creates a lot of work for publishers and a lot of work for people like us, because we do this work for publishers. But I feel really the way forward is to have your references. Once we've done the BibTeX, tech is only a few people or a minority use tech or BibTeX. And of course, all the geeky stuff that we've been talking about, who is going to use BST, etc. But I think once tech has done its job, what we want is to keep that information. We should keep it as a structured XML file. So each reference is an XML file saying what the name is, what the basically standard way of describing, and then from that you can press a button using things like citation style language that we talked about before. That can create any style. So we should go that way around, whereas a lot of time is being wasted going back and forth and proofreading. Someone sits and proofreads that the commas in the right place. Still doing it.
I'm going to share with something. I don't know if you can see this. This is a library book from the Open University, and it's got the ISBN, and it's got an OU library identifier. So this is the standard thing in libraries, is that libraries, every item in a library, well, not every item, of course, but modern books have an ISBN, but the book is a physical object. The book is a physical object, and as a physical object, it's given a number, just as your registered car is given a number plate. They call it a number plate. And when the Postal Service was developed, houses were given numbers. So they didn't have numbers before the Postal Service, I believe. And art libraries, personal libraries, the Duke of whatever, would have a catalogue of all the paintings, and there'd be a number attached to the back of every painting. So this sort of physical objects having numbers and having a catalogue of things has got a really long history. And your share certificates have numbers. Your banknotes have numbers. Numbering things is something that human beings have been doing for a long time. And what we've got with print is we have identical copies, or nearly identical copies. And so there we have this sort of bifurcation of multiple physical objects, but they're the same. And then the question of identity of objects arises. If you're dealing with handwritten letters, then you never get two handwritten letters that are identical. They're all distinct, and all human beings are distinct, even if they're identical twins. So the problem we've got is numbering these objects that are intended to be identical, the digital objects that are intended to be identical. And Git solves that by using a secure hash that's computed from the content of the object. And the chances of, well, they've got a bit worried that there's a theoretical chance of they double the length of the size of the hash, and the theoretical chance is going to be smashed to smithereens with the new version of Git that will use longer, more secure hashes. And that's almost certainly the way these things are sort of going. So that's something that didn't exist in 1993, was using secure hashes as a content addressable store. So it seems to me as though there are sort of two fixed points here, or maybe three. One of the fixed points is that when I say every object, I mean every object up to equality, you know, that you and I can both have copies of the same object. So every object should have a number that is a small number, you know, like the PubMed identifier. So there should be some accession list where things are put in and you get a number. And then there should be a biggish number, which is the secure hash, so that two people can see that two things are identical without having to swap them to and fro. And that's why Git works so well as a distributed version control system, is that you just compute the hash at the root of both sides. Me and Carve compute the hash at the root. And if they're the same, then we have the same tree. We don't have to communicate much information. We just have to communicate the hash at the top. And if they differ, then we say, oh, what are the things that went into the hash at the top? And then we look for differences and so forth. So those are the two things which are purely numerical. The one is the accession table, and the other is the secure hash. And then the third thing is something that is intelligible to human beings, such as Nelson's article on BibTeX in 1993. So those at least the three corners, if you like, of the object being referenced has a secure hash. Oh, the fourth thing is the object itself. So there's the secure hash of the object, there's the object itself, there's the accession number, and then there's the human description of it. So the human description of it might be this pleading submitted to this case. So there are at least four things involved there, and they all need to be sort of fitted together and respect each other. And one of the parts of the reference system, which BibTeX and other reference systems provide, is it's a way of putting in one document a secure reference to another document, by which I mean that the reader of the document can get hold of exactly the same thing as you thought you were referring to. And that's the function of the reference. So this book is called Joseph P.S. Kung, A Source Book in Matroid Theory, and that should always produce the same book. And that was the revolution that print wrought. Print produced identical copies, and that was the print revolution. The print revolution was that you didn't have multiple hand copies of the Bible, all with the different paginations and errors and so forth. You had the same copy. And so I could say to somebody, well, what they did before print was they'd quote chapter and verse for the Bible. You know, if you're having a theological discussion, you quote chapter and verse for the Bible. And some of the verses are so well known that you just have to show the chapter and verse, and somebody who knows it knows it. So the print revolution allowed referencing to take place. The sort of, you can reference a letter in a print book, and you'd say such and such an item in such and such a collection of so and so's papers. You can do that, but often we reference page 57 of such and such. That's the sort of referencing that print and then computers have allowed. And we've all got that problem of referencing, including people who've got large collections of family photographs and anything else like that. So all the digital stuff is organized by Google in one way, and it's organized by ChatGPT and the artificial intelligence people in another way, and it's organized by the lawyers in another way, and the mathematicians in another way, and the biologists and PubMed in another way. But they've all got that same basic problem of, well, maybe not the artificial intelligence people, of what's the object being, you know, the uniqueness up to equality of the object being referred to, and then how do we refer to it? And you've got the object, you've got the secure hash, you've got the accession number, or if we prefer, the storage location on a disk. It's all these sorts of different ways of handling the information, and the information itself. And something I'm realizing is that it's a bit like in biology, we have a gut biome that is actually considerably more important than we realized for our health. And for data, we have metadata. And the metadata can be really important. The metadata is perhaps 20% of, 20% of the world's useful data is in fact metadata. And the commonplace expression of that is, it's not what you know, it's who you know. I know that's not the same, but the metadata is really important. And giving somebody the right reference, I don't mean employment reference, but if you say, oh, if you look in such and such a book, you'll find material information that's important to you. That's really important. And it used to be that the reference librarians were very, very good at that. You come in and you say, I want to learn something about so-and-so, so-and-so. You say, oh, you should try and go and so-and-so, so-and-so. So that sort of role of the librarian is metadata. The library catalog is metadata. And can you imagine a library without a catalog? It's horrible. So the BibTeX is part of the metadata system. And we should sort of think of it in that way. And perhaps that's my plea for rethinking all of this insofar as it's necessary. And I'm not convinced that BibTeX needs to be changed or should be changed. But there is a changed context from 1993. And so it would be wonderful if it doesn't have to be changed. But we shouldn't rely on that. I've given my little speech to finish. Anybody else can give a little speech to finish if they want to. Tom does.
Nelson, you put up a script briefly, and I actually did a screen capture and was able to get the end of it, but I didn't catch the beginning.
I'll mail the script to Jonathan, who can then post it to everybody.
Okay, that'd be great. I looked for the script in your website and couldn't find it. There's a reference to it, Doi to Bib, but there's no link to it. So,
I'll have to
see if
that out there. It was just informally developed, and as more and more publishers are getting data to the Crossref agency and the DOI agency, it's becoming more and more important to have an easy way to pull data from them.
Yeah.
Without having to manually reformat it from the typical web display.
Well, it'd be great because it will cover the physics, which isn't in PubMed, and then I don't have to convert those. I could get at least a baseline for it.
You mentioned ecology as an interest area. I cover a fair number of journals with ecol in their titles, so you could snarf everything from our website if you choose to.
Oh, you mean you have references?
Ecological modeling and several others.
Are you into theoretical biology?
Marginally, because the top floor of the building where I sit is occupied by mathematical biologists. We might be the largest math bio group in the world. It's a major area of interest in applied mathematics in my department. And so I cover journals that are of interest to them.
I see.
And
oh, you cover them. You cover those journals for them.
Yeah, so because my feeling is part of my job here is to support the department, and if I can make the literature they need readily available, this helps. You had mentioned PubMed, and a few years ago I took a complete dump of the PubMed data and wrote software to convert it to BibTeX. The issue I ran into there is that proper nouns and titles need to be brace protected, and PubMed has made no attempt to identify such things. Yeah. And it was just, I don't want to put out data that people associate with my name that hasn't been properly braced, because it becomes unreliable web data. So I haven't completed that project, and I don't know of any good solution to it. Humans
well, I
have
sort of
look at a title. I mean, for example, if you see a title that has in it Black Sea urchins, are these urchins from the Black Sea, or are they urchins that are black? And if they're from the Black Sea, it's capital B, capital S. But if they're Black Sea urchins, it's all lowercase.
Yeah.
And sometimes to disambiguate, I actually have to look at the abstracts and sometimes the bodies of articles to figure out what did the author mean here. And had the publisher put in this markup correctly to begin with, there wouldn't be this ambiguity. But regrettably, the ambiguity is wide in the biological literature.
Yeah, so I solved that by putting I just ended up putting curly braces around the entire title. And then
the problem you run into is a publisher will reject your reference list because it's got up and down casing when their house style says down case.
Well, I haven't ever had a publisher object to that yet. And so I just go into the title and I just correct the title corresponding to the PDF that they provided. Yeah. And no journal has ever objected to that. I'm just trying to get close to whatever the title was in the paper. Yeah. Well, it's been an interesting meeting, Jonathan. Thank you.
I'm surprised in a very pleasant way as to what happened, and it fills me with a certain amount of optimism because of the positive energy that there was, and also the relevance that all of this stuff is relevant and important. Nelson, would you like the last word?
Yeah, let me just make one note here. Reminder when I get back to lunch to post the script to you so that you can make it available to the list of participants. I'm also trying to get it on the web in some form. No, I think we've done a pretty good job of discussing a number of the issues associated with bibliographic markup, but there's certainly much more to be said. The BibTeX information and tutorial website that I created has a lot more detail, discusses the problems of names and accuracy of data from various web sources and so on. I try very hard in the bibliographic work I do to prepare entries that will stand for all time, that do not need fix-ups. Regrettably, most of the bibliographic data that's out there that you can find in arbitrary Google searches is fairly low quality. We had in the 1990s access to a couple of commercial databases that were getting off the ground and providing references to journal articles, but I found they were effectively useless because they truncated author lists without telling you, and they would also truncate titles. And so I just gave up on using them. It was just too unreliable. But now that most publishers are getting electronic data into their websites for their journals and their books, we have a much better chance of getting correct data. Another thing I do is extensive spell checking. I run 4 or 5 different spell checkers on every document I write and every bibliography entry I write or create. And what I've observed is that there are few publishers and I'll give Elsevier and Elsevier and Springer and the American Math Society and SIAM, the Society for Industrial Applied Math, strong marks for getting pretty correct data. It's rare I have to make spelling corrections in data that I get from those publishers. From other publishers, less well-known ones, or in-house journals that are edited by a single faculty member at some university, life is not so pleasant, and there are lots and lots of errors and fix-ups. So, but I try as much as possible to correct things. Another thing I do is, as part of the bibliographic processing for every new bibliography, I extract the braced words that are in titles and put them in a big list that is now tens of thousands of entries. And so when I see that word appearing without braces somewhere else, that's a flag that perhaps it should be braced. And I have a little simple Emacs command in a pull-down menu that does that check for me. It gives me a list of the questionable bracing that I can then repair. And because that list is, for every new bibliography entry, that list gets augmented, it gets better and better all the time. But it doesn't help me if I were to branch into a new field. If I were to find romantic literature, it wouldn't be good at finding names that are proper names in those fields. But certainly in the sciences, and including theoretical biology, I have a pretty good coverage of such names.